Okay, so the focus of this lesson, again, we're continuing our study in exponential functions, but the goal of this particular part of exponential functions is on solving application problems. So let's look at number one. So number one, you have this problem, and we write this number one, and it says, in 1992, a particular baseball card was valued at $7. And the value of the card can be approximated by this function. Let me go ahead and rewrite the function. You may not be able to see it very well, but here's the function. It's f of t is equal to 7 times e to the 0.123 times t. All right, so that's this function here, where t represents a number of years after 1992. So t is a number of years after 1992. That's important. Assuming that the value of the card continues to grow exponentially, so that's the idea of that exponential base that you see, so the exponential function, predict the value of the card in 2023. All right, so basically, you got to figure out, see, in your function, the only variable you see is t. All right, so you see the number e. Now remember, e is an irrational number, and we're going to use the value from the calculator to do this, but the variable is t. So remember, t is the number of years after 1992. So the number of years from 1992 to 2023. All right, so what the best way to do that is just, I mean, you could say, well, how many years are there between 1992 and 2000, and then from 2000 to 2023, right? But you can just subtract. Just say 2023 subtract 1992. So t will equal 2023 subtract 1992. And so that's going to be how many years? Let's see, 2023. So all I'm doing is just subtracting this. Minus 1992. And that gives us 31 years. So t is 31. And then all you do is go back and you substitute, you find f of 31. So t is 31, so you can find f of 31. So f of 31 then will equal 7 times e to the 0.123 times t, and t, remember, is 31. All right, now you got to know how to use your calculator with this. So keep in mind that the exponent is a product of two factors. You have 0.123 and you have 31. So on your calculator, if you're gonna type it in as you see it, then you need to do this. You're going to say f of 31 equals 7 times e, and put that in parentheses or brackets. So 0.123 times 31. Okay? So that's how you can put that into your calculator. Remember, this is multiplication right here. All right, so let's go ahead and do that. So you're going to say 7. All right, so 7. Make sure you know how to use your calculator. 7 times e. Now to get to e, you have to press, see where that ln button is, and it's right. You have to press that second function to get to it. So second e, so you see that shows up. Then it automatically puts some parentheses in there for you. You just got to make sure you close it. So 0.123 times, see the multiplication symbol, 31. Go ahead and close it, close the parentheses, and then press equal. And so let's see, it says, so let's go ahead and round this to, it didn't tell you how to round off, so let's go ahead and round off to the nearest whole dollar. So f of 31, so 31 years later, this baseball card that was worth $7 originally is now worth $317. So $317. Okay? All right, so that's number one. Number two, so make sure you know what that means. So basically, in what this means is that in 2023, the baseball card is worth $317. Okay? All right, number two. So the number of bacteria in a culture is given by this function. And so the function is this. It's b of t equals 4,000 times 2 to the t power. All right, so you're given this exponential function. where T is a time in hours, so T is in hours, and part A. How many bacteria will grow in the culture after the first 6 hours? So T in this case is 6, so this is T, and the only variable you see is T. So then you're going to say B of 6 then, B of 6 after the first 6 hours, the number of bacteria in the culture will be 4,000 times 2 to the 6th power. And so using your calculator, you're going to say 4,000. All right, and then times, so 4,000 times, and then 2, so you can say 2 raised to the 6th power, just like this, equal, and so 256,000. So 256,000. So how many bacteria will grow in the culture after the first 6 hours? So after the first 6 hours, the answer, there will be 256,000 in the culture. So after the first 6 hours, after the first 6 hours, there will be 256,000 bacteria in the culture. Okay? And then they want you to do the same thing with 10. So you're going to say B of 10, you do the same thing, will be 4,000 times 2 raised to the 10th power. And let's see what that is. So 4,000 times 2, so 2 raised to the 10th power equals, so that's 4,096,000. So 4,096,000. All right. So after the first 10 hours, there are 4,096,000 bacteria. Okay. All right, number 3. Let's look at number 3. So in number 3, we have this. All right, so the radioactive, here we go. So this is number 3. The radioactive decay of radium-226 can be described by this equation. Let me go ahead and rewrite the equation. So the equation is A equals C times e to the negative 0.00479 t. Okay, so that is this right here. All right, where C is the original amount of radium, so C is the original amount of radium, and A, this A here, is the amount of radium remaining after T years. So T is in years, so T is your time. So they tell you that if 32 milligrams of radium are sealed in a container now, how much radium will be in the container after 4,000 years? All right, so notice there on the right side, there's this variable C and this variable T, okay? And on the other side, on the left side, you have the variable A. Notice that this 32, it says this, if 32 milligrams of radium are sealed in container now, so you got to determine which of these variables represent 32. Obviously, you know it's not T because T is this 4,000 years, right? So remember what C is. So C is the original amount of radium. Well, this is your original amount of radium. So C in this case is 32, okay? And T is 4,000 years. And you're asked to find, this is what you're said, how much radium will be in the container, so that's A. Okay, so remember A is the amount of radium remaining. Okay, so let's go ahead and substitute. So we get A equals C, which is 32, times e to the negative 0.00479, and then times 4,000. So times 4,000. And when we put this in the calculator, we're going to put this in parentheses, all right, because you're multiplying two numbers together. All right, so remember how to use your calculator. You got to know how to use your calculator. So in this calculator, to get to E, remember you got to press second. I'll just show you right now. You're going to press second, and then the ln button. And you see that's your E function. All right, so you're going to say 32. So 32 times, and then E, so second ln. Okay, see right here. And then it automatically puts a parentheses for you. So you're going to say negative 0.00479 times 4,000. Close the parentheses, and then press equal. So the amount of radium that will remain and contain after 4,000 years, so 32, you start out with 32, you're going to end up with this amount. All right, so it's going to be 0.00000, let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 5, 3. Okay, so that's the amount of radium remaining. So you went from 32 to this amount. Okay. All right. So let's look at number 4. All right, number 4, you have the atmospheric pressure measured in pounds per square inch is given by this equation. So you have this exponential equation. I'm going to rewrite it. So P equals 14.7 times e to the negative 0.21 d. Okay? All right, so where d is the distance in miles above sea level, so this d here is a distance in miles above sea level, and then P is your pressure. And remember, pressure is in pounds per square inch. All right, and so the question is, what is the pressure? So you're solving for P. What is the pressure in pounds per square inch on an airplane flying 12 miles above sea level? So remember, D is the number of miles above sea level, so this is D right here. And so all you do is substitute in place of D, you're going to substitute 12. So we get P equals 14.7 times e to the negative 0.21 times 12. Okay? I'm going to put that in parentheses in the calculator. So remember, that's 0.21 right here. All right, so let's go ahead and put it in the calculator. So now you're going to say 14.7. So 14.7 times, you got to get E now. So you can press second ln, just like this. And then negative 0.21 times 12. Close the parentheses and press equal, and you get 1.18. Now they didn't tell you how to round off, so let's go ahead and round off to the nearest hundredth. So the nearest hundredth. So round to the nearest hundredth. So round to the nearest hundredth. Now remember, the nearest hundredth can also mean 2 decimal places. So sometimes they'll just say round to 2 decimal places. Sometimes they'll say round to nearest hundredth. Okay, so to nearest hundredth. Remember, this is the tenths place right here. This is the hundredth. So the 8's in the hundredths place. So the round nearest hundredth, you got to look at the thousandths place as well. So if that's 5 or larger, then the 8 becomes 9. So the pressure is going to be approximately equal to 1.18 pounds, and it's what, pounds per square inch? So pounds per square inch. Okay? All right, that was number 4. All right, let's look at number 5. So number 5, you have this. You have the average salary of a baseball player increased exponentially between 1993 and 2009. The average annual salary, A, in millions, can be approximated by this equation. So let me go ahead and write the equation. So it's A equals 1.062 times e to the 0.075 t. All right, so that's this equation. All right, so where t is the number of years since 1993. All right, so it looks very similar to a problem we had earlier. So the first part says is determine the average salary in 1997 and in 2006, and you go around to the nearest dollar. So in 1997, so let's figure out in 1997. So in 1997, all right, we're going to figure out the average salary. So A is the average salary. That's what you're told, the average salary A, and it's going to be in millions. So A will equal 1.062 times E to the 0.075 times T. Now remember, T is the number of years. So T is the number of years since 1993. Well, in 1997, so how many years are there between 1993 and 1997? Well, all you got to do is just subtract the two. So 1997 subtract 1993 equals 4. So T is 4 here. Okay? So remember, T is 4. Okay? And so just use your calculator. And so remember, round to the nearest whole dollar. So using your calculator, you're going to get 1.062 times E, so second ln, right here, okay, raised to the 0.075 times 4, okay, close the parentheses and press equal, and to the nearest whole dollar, we have this. Now remember, nearest whole dollar said, so when you round off to nearest whole number, the whole dollar means a whole number, is just 1, okay? So this is 1 million. So remember, 1 million because you're told that it's in millions right here. So keep that in mind. So 1 million. So in 1997, the average salary of a baseball player was 1 million. All right? Then it says this. What is the average salary in 2006? So in 2006, so again, we got to find T. So from 1993 to 2006, how many years is that? So 2006 subtract 1993, and that gives us 13. Okay, so we're going to say A, so that's going to be this one. So A equals 1.062 times E to the 0.075 times 13 this time. And to the nearest whole dollar. So let's see what that is. Let's see. So 1.062 times E, so ln, raised to the 0.075 times 13, close the parentheses, press equal, and you get this. So it's like, what, 2.8? But we're going to just say 2. So 2 million. Okay. Now you got to be careful with the way I wrote the answer, because it did say to nearest whole dollar, right? Notice that this is in millions. So let's just go ahead and leave it like that for a moment. So you go from 1 to so the average salary in 1997 was 1 million, and the average salary in 2006 was 2 million. All right. And so the question is, it's actually a little bit more than 2 million. Oops, sorry, nearest whole dollar, excuse me. It's not 2 million, it's what? It's 3, right? Because you have to look at this. So if this is 5 or greater, this becomes 3. Sorry about that. So that's 3. Okay, so now it says this. What was the percent of increase from 1997 to 2006? So remember, percent increase, so you got to remember something from a previous course. So percent increase or percent change, let's do percent, let's define percent change. So percent change is okay, so the percent change, and I said change, we could say percent increase, decrease, percent increase, decrease. Remember, is the change over the original. Okay, so the change from 1997 to 2006 went from 1 to 3. So you're going to say 3 subtract 1 divided by the original, and the original was 1. So that's 2 divided by 1. All right, so 2 divided by 1 change to a percent. So you got to change the number 2 to a percent. So remember, to change a number to percent, you move the decimal point 2 places to the right. So this becomes 200%. All right, so 200%. So that's a percent increase. All right, so that's number 5. Let's look at number 6. Number 6, we have this. Number 6. All right, so number 6. So it says this: the price P in dollars of a specific car that is X years old is modeled by this function. I'm going to go ahead and write the function over. So P of X equal 24,650 times 0.80 to the X power. All right. And then it says this. So it says, how much should a 3-year-old car cost? So remember, X is the, so let's read again, the price P. So P is the price of a car that is X years old. So X is the number of years the car is. So if you're told the car is 3 years old, then that's your X. So X is 3 here. So X equals 3. So you're going to substitute in place of X, you can substitute 3. So we get P of 3 will equal 24,650 times 0.80 to the third power. And let's see what we get. So we get 24,650 times 0.80 raised, just like this, raised to the third power, press equal, and you get $12,620.80. So that's about $12,620.80. They didn't tell you how to round off, so I'm just going to go ahead and use the cents as well. So you could have rounded off the nearest whole dollar, and that would have been 12,621. Or you could say 12,621. Okay? All right, so that's the cost of the car that's 3 years old. Let's do the next one. So how much should a 7-year-old car cost? So in this case, X is 7. So we do the same thing. So P of 7 equals 24,650 times 0.80 raised to the 7th power. So using your calculator, let's see what we get. 24,650 times 0.80 raised to the 7th power equals, and this time it looks like it's $5,169, and so the nearest, remember we're dealing with money now, so you round to nearest hundredth. So to nearest hundredth, that's what, 48 cents? Since this is 5 or greater, the 7 becomes 8. So 48 cents. Okay. If you wanted to, they didn't tell you how to round off, so you could round nearest cent, or you could round to nearest whole dollar. So the nearest whole dollar, since this is less than 5, this stays 9. So you would say $5,169. So that's how much this car that is 7 years old would cost. All right. Okay, so then it says this: explain the meaning of the base 0.80 in this problem. So remember, since the base is less than 1, notice what's happening to these values. These values are decreasing. See that? So they're decreasing. So you're getting a decreasing function. So this is a decreasing function because the base is less than 1, between 0 and 1. And so what this 0.80 means is that after each year, the value of this is decreasing by 80%. All right, so that's what this says right here. So for this one, explain the meaning of the base 0.80 in the problem. As each year passes, the car is worth 80% of its value from the previous year. So it decreases 80% each year. So that's why you're like, well, geez, after 4 years, it decreased a lot. Yeah, because it's losing 80% of its value each year. Okay? Or it's worth 80% of its value each year. Excuse me. It's losing 20%. All right. Okay, so that was number 6. Let's look at number 7. So number 7 is the same idea. You're dealing with a car, except the variable is a little bit different in this case. Instead of V, instead of P rather, in the previous problem, instead of P for price, they're just calling this V here value. All right, but T is the same thing. So T is how old the car is. X here was the how old the car is. Right here we're using T. So just make sure you read the problem to understand what the variables mean. So let me go ahead and rewrite the function so you can see what it is. So V of T equals 19,456 times 0.85 to the T power. All right. And so part A says this, according to this model right here, what is the value of a brand new car? Well, a brand new car would mean that T is 0, okay? And so you're going to substitute in place of T, you're going to substitute 0. So you get V of 0 equals 19,456 times 0.085 to the 0 power. Well, most of you know, or all of you know, that any non-zero number raised to the 0 power is 1. And then 1 times 19,456 is 19,456. If you do not know that, still use your calculator. You're going to say 19,456 times 0.085. I'm sorry, it's 0.85. Okay, 0.85 times, let me go ahead and change this, times 0.85 raised to the 0 power. And notice you get 19,456. So that's 19,456. Okay? So that's the value of a brand new car. In fact, remember that this number right here is the initial amount, is the original amount. So the original amount of the car is this right here. And then all of a sudden it's losing 15% each year. So it's keeping 85% of its value after each year, meaning that it's losing 15%. All right. So then part B says, according to the model, what's the value of the car of a 2-year car? Well, remember, this number is less than 1 and greater than 0. So it's particularly less than 1. So that means it's decreasing. So remember, your value should decrease. So because it's losing 15% each year. So it's keeping 85% of its value, but it's losing 15%. Okay, so you're going to say V of 2 then will equal 19,456 times 0.85 raised to the second power. So T is 2. All right, so T is 2. And so using your calculator, we get 19,456 times 0.85 raised to the second power. And that's going to equal, and it says nearest whole dollar. So, well, the nearest whole number rather. So we're going to get, let's see, 14,000. And then notice the tens place is greater than 5. So the ones place becomes a 7. So make sure you know how to round off. So 14,057. So 14,057. Okay. So after 2 years, you went from 19,456 to 14,057. In C, how much would this 8-year-old car be? So V of 8, so this time T is 8. So will equal 19,456 times 0.85 raised to the 8th power. And so obviously it will be a lot less, right? So 19,456 times 0.85 raised to the 8th power equals, and then to the nearest whole number, see the tens place is 5. Since it's 5 or larger, the 1 becomes a 2. So 5302. So $5,302. Okay? So that's the value of the car, an 8-year-old car. All right, so that was number 7. Okay, so that was number 7. Let's look at number 8. So in number 8, we have this in number 8. So this is the last one we're going to look at. So it says this: if a single pane of glass obliterates 6% of the light passing through it, the percent P of light that passes through n successive panes is given approximately by this function. So here's your function. So P of n equals 100 times 0.94 raised to the n power. So notice this 0.94. So you see that 6%? So that represents 94%. So you see where it says that it's losing, that it blocks 6% of the light. So 6% of the light is blocked out. So it's keeping 94% of the light. Each pane is keeping 94% of the light. So it's blocking 6% of the light. Right. So you don't have a very clear glass. It's where 100% of the light goes through. Only 94% of the light goes through. That's what this means. So it says, what percent of the light will pass through 7 panes? So you have 7 panes that are stacked, and you have light going through all 7. All right. So n, remember, n is the where it is. N successive panes. So n is a number of panes. So you're told 7 panes. So n is 7. And you want to round to nearest whole number. So P of 7 will equal 100 times 0.94 raised to the 7th power. And so let's see what this is approximately equal to. So 100 times 0.94 raised to the 7th power equals, so to nearest whole number, see that 10th place is 5 or larger, so this 4 becomes 5. So 65. All right. So what percent of the light will pass through 7 successive panes? So you got to say 65%. Make sure you put the percent symbol. All right. She's got to put the percent symbol. All right. Okay. So instead of 100% of the light, only the instead of 100%, instead of this being 100%, it's not 100% because each pane blocks off 6%. Okay. So you get 65% of the light being blocked out by 6 successive panes. All right. Okay, so keep in mind, and I got to be a little bit careful. So you have, make sure you understand this. A single pane of glass obliterates 6% of the light passing through it. So the first pane, 100% of the light touches it, okay, but 6% is lost. The next pane, whatever amount of light goes through it, you lose 6% from the original. So just it's a little bit hard to understand this idea, but just know how to use this formula. B, what percent of the light will pass through 15 panes? So remember, you have the first pane, then the second pane, then the third pane, fourth pane, and so on. So that first pane, you have all that sunlight going through. But the second pane, not all of that same sunlight's going through it, but it's still losing 6% of what's going through it. Okay? So it's not 100% each time. 100% of the light through each pane. The first pane hits 100%, it blocks, that first pane blocks some of that sunlight or that light, and then the second pane will block 94%, I'm sorry, will block 6% of that, and then another 6% of that, and so on. So what percent of the light will pass through 15 panes? So n is 15. So you're going to say P of 15 will equal 100 times 0.94 raised to the 15th power. So you see that's what that 100 is right there. So each so the original pane, 100% of that light touched it, and then what came out was 94% of that original light. Okay, so we get, when you use your calculator, you're going to say 100. So 100 times 0.94 raised to the 15th power. And I must have done something wrong. Let's do this again. Yeah, I messed up right here. All right, so 100 times 0.94 raised to the 15th power. So the nearest whole number, it's see the tens place 5. So since that's 5, I have to add 1 to the 9. So this becomes a 40. So so what percent of the light will pass through 15 panes? So you have 100% of the light going through that first pane. At the end of 15, only 40% of the light will go through that last pane. Okay? All right, and then C says it's explain the meaning of the base 0.94. So just remember, I tried to discuss that as we went through this. May not have been a good discussion, but what that 0.94 means is this: each pane allows only 94% of the light to pass through it. So let's say you had 3 panes. So you have that first. So let's say this is the first. So you have your light. All right, so you have 100% of that light that's going to touch it. As it goes through, it's going to lose 6%. So only 94% will come out. Of that 94%, that other pane is going to block out 6% of that. So you're going to have a certain percentage come out of that. And then that next pane will block off 6% of what's going through it, and so on. So it's not 100%, it's not 100 each time. It's 100 through the first one. It loses 6%, so only 94% of the light will come through. Then that other pane will block 6% of that 94%. That's what this is. Okay, so that is right here the some problems on solving application problems involving exponential functions.